Tahniah! Secara langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Secara langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
So YouTuber Tuisyen Percuma, usaha sama bersama e-didik dan Kelab Guru Malaysia, bermula percuma, selamanya percuma. Untuk mendapatkan keberkatan kita pada petang ini, okey, mari kita berdoa sekejap bagi yang Muslim. Kita membaca umul kitab Al-Fatihah. Baik, apa khabar semua? Okey, harap semua berada dalam keadaan sihat, okey, dan bersemangat ya untuk meneruskan kelas kita pada petang ini. Saya perkenalkan diri dulu, nama saya Cikgu Wahidah binti Zakaria daripada Kolej Matrikulasi Pahang. Okey, dan petang ini ya, kita akan ada kelas tuition percuma bersama Cikgu Ailin, okey, di channel Teacher Ailin bagi subjek Matematik T Stpm Prayu. Bagi sesiapa yang belum subscribe lagi channel Teacher Ailin, sila tekan butang subscribe di bawah. Okey. Dan juga loceng untuk notifikasi video seterusnya. Baik, kita perkenalkan dulu Cikgu Ailin ataupun nama sebenar beliau adalah Liu Ailin dari Pusat Tingkatan 6 Sekolah Menengah Kebangsaan Datuk Penggawar Timur Pasir Gudang, di mana subjek matematik T yang akan diajar pada petang ini bertajuk Revision, Sampling and Estimation. Jadi kelas ini akan berlangsung lebih kurang dalam 1 jam dan bersama kita di konti juga pada petang ini kita turut serta adalah Cikgu Zana ataupun Puan Zainariah Abdullah dari Pusat Tingkatan 6 Sekolah Menengah Kebangsaan Tunku Ampuan Durrah Seremban. Hai. Dan Madam Rosmaya binti Muhammad dari Pusat Tingkatan 6 Sekolah Menengah Jenis Kebangsaan Yu Hua Kajang sebagai permati. Baik, sebelum kita teruskan kelas kita, ingin saya ingatkan kepada semua pelajar dan penonton yang ingin menghantar komen, gunakan bahasa yang sopan dan gambar profil yang bersesuaian. Okey, dan saya yakin ya semua cemerlang dan berdisiplin. Okey, dan sila fokus pada isi pelajaran yang akan disampaikan oleh Teacher Ailin. Okey, mari kita serahkan kelas kita kepada Teacher Ailin. Dipersilakan.
Hello. Hi. Good evening to CE, How? Alright, NG. Okay. So, I think yes, just like Teacher Im said, this will be your last Maths T online tuition class, right? So, you ask your friend to join us, okay? JC, oh, I know already. Now JC, I know who is that. JC is Jia Chong. I can. Is that so? JC, Jia Chong. Hey, Jia Chong, good evening. All right. So, so call your friend to join us. This is your last online tuition. So, how do you feel now? Okay? Happy? Excited? Or sad? Happy because, oh, you are going to sit for your exam finally. Finally, you have been waiting for so long time. Okay? Excited because you are going to finish your Form 6 life. You are going to fly. You are going to enter your university, college, and further your study. Excited. You can't wait to finish your exam. Okay? Anybody feel sad? You're going to leave us? Any going? Okay? Anybody feel sad? Leave us. You're going to leave us soon. Okay, but no lah, don't leave us lah. Okay? Come and support us once a while. Okay? Jenguk balik. Come and invite us. Support teacher Ailin. Support teacher Im. Support our Cikgu Zana or our AYU tuition. Okay? Don't leave us. Come and jenguk and visit us for time to time. All right. So, and since we are going to have, this is the last. So I think at the end of the session, I will spare some time for you to give a little bit speech, a short speech. So get ready. Okay. You should thank all your teachers, chemistry teacher, your physics teachers, and your MURID teachers. Okay, thank them for your guide. Okay, so later I will send you the link. Okay, get ready your this one, your speech, and okay, we say bye bye later on. Okay, don't worry, bye bye, class. Okay, now I think let me start. All right. Okay, now today I'm doing the revision for the chapter 4. Chapter 4. Chapter 4 is about sampling and estimation. Okay, so actually when come to term 3, chapter 4, chapter 5, chapter 6, actually you can score now. Okay, so actually you can score, and generally compare with term 1, term 2, and term 3. Term 3 actually is the easiest term. So please do properly and score, make a good score, so that overall when you come to final you can push up all your grade. Okay, so now, so today I'm doing this one. Let me start. Okay, sampling and estimation. So today I'm not going to teach. I'm going to just like help you to recall back all the notes in sampling and estimation. Okay, so when doing revision, that is very important thing is you must summarize or you must make your own notes about that topic. Make your own note. Make your own notes means the note is according to your understanding, according to your own understanding about the topic. It is not according to your teacher's note. It is not according to somebody's note. According to what you understand about that topic. Okay, so you must make your own note. That is very important. Summarize what you have learned in that chapter. Okay, this will help you to memorize. If you want to memorize or you want to recall back based on your own understanding, that is very important. So for today, I try to summarize for you, but this one is based on what I understand. And if this one is for your reference, if you want to use this one as your reference, this one is according to my understanding about this chapter. Okay, first, this chapter, sampling and estimation. So generally we have two sections, sampling and estimation. Okay, so in sampling, what are the things that you learn? Okay, sampling. Okay, there are two main things that you learn in this sampling. Okay, now I want to ask you, what are the things you learn in sampling? Here I have two boxes here, means there are two main things that you learn in sampling. Can you tell me what are the two main elements in sampling?
You can type in the chat.
Yes, you type in the chat box. What are the two important thing that you learn in sampling?
Okay.
Maybe I can give you clue. The first thing is about sample mean. If the first thing is about sample mean, so the second one is about what?
Simple question.
What you learn about sampling.
Okay, come
The
on,
second one is
Atira. Okay, NG.
two main thing, two different, two important component. One is sample means, the other one is what?
Population means. Chai why her answer
Population mean.
population mean.
Population mean is
It
about
wrong.
mean. About mean. It is under here, mean. The other one is not the mean. Not the mean is what? Sample what? One is sample mean, one is sample what?
Another one. Okay, what about another one? Sample variance, random sample. So which is the correct one?
Sample variance. Sample variance is M sample. Okay, I can see Tuisyen. Tuisyen said sample proportion.
Yeah, sample
Yes,
proportion.
the other one is sample proportion. These two main things that you learn in sampling. Okay, when you do sampling, you find you calculate about sample mean, you calculate about sample proportion. Right? These are the two main things that you learn in section sampling. All right. So now we will go one by one. Okay. This part we have a lot of formula. This part we have a lot of formula. Later estimation later. Okay. Now we go to sample mean first. About sample mean. Okay. Sample mean also we have so many things. All the formulas under sample mean. Okay. First thing is sampling distribution of sample mean. What is the sampling distribution of sample mean? Can someone? Sampling distribution of sample mean. We use what distribution to do approximation? What distribution?
So come on, class.
Can sampling distributions of sample mean. Sample mean means bar x. Bar x is this one, approximate to what? Sampling distribution of bar x mean bar x approximate to what distribution? We use what distribution to do?
So Wong
Okay.
and Ailin said normal distribution.
Yeah, we use normal distribution as the approximation for sample mean. Okay,
Congratulations.
normal, yes, normal. Okay, now normal distribution to do the approximation of sample mean. Okay, so normal approximation, we need two parameter. What are the two parameter? What are the two parameter? Okay, means bar x, then wavy, normal in brackets. Inside the brackets, you have two number. The first number is what? The first number is what? Mean and variance. Yes. Okay. So we use, this is the sampling distribution for sample mean. Bar x is sample mean. Okay, we use the normal as the approximation for sample mean with two parameters. One is population mean. Okay, when you come to sample mean, the normal one, this one is normal variance. If this one is sample means, you must divide by sample size. And this one is the very important. Students always get mistake. If this one is bar x, okay, so this one, the second number must be population variance divided by sample size. This is the very important. Okay, this is the sampling distribution of sample mean. Okay, since sample, we take sample from population, what, yes or not? So means the distribution of the sampling is depends on the population. Population punya distribution. Okay, so let's say the population distribution, we take the sample from binomial population. Okay, let's say the original population is binomial. Then what is the sample distribution for this one? If the population is binomial. So, what is the first number? What is the first number? That is bar x approximate to n. You will have two number. What? First number is what? First number we know that it is the population mean. But population mean if the population is under binomial. So what is the population mean for sample mean here?
Okay, come on student. Try.
Okay.
Okay.
Yes, I can see Leong Un. The first number is NP. The second number is NPQ. First number is NP, correct? Sharon Tay, correct? Okay, Xuan, correct. But second number, see this one. Okay, remember, second number is variance must be divided by sample size. So for population, binomial population, the variance is NPQ. Okay, NPQ, but you must divide with sample size. Here, I try to use other alphabet. This one, N is the parameter for binomial. Okay, M is the sample size. Okay, I try to use the different alphabet so that you won't get confused. M is the sample size. So remember, every time when you want to write the distribution for sample mean, this part, the second number, must be divided by the sample size. Okay, it is not only NPQ only. If NPQ, it is population. Now we want sample mean bar x. If it is x only, then no need divided by sample size. But now it is bar x. Once you see bar x, here the variance you have to divide it by sample size. Okay, so if you want to use n to do the approximation, there are two conditions. You must have two conditions. Then only you can apply n. What are the conditions? Do you know? What are the two conditions? If you want to use this n as the approximation of NPQ divided by m, you must have two conditions. Must have two conditions. What are the conditions? Can
anyone try?
Can anybody try? It's wrong, doesn't matter, because you want to learn something. What you learn from your mistake doesn't matter. All right. Sharon Tay, n must be greater than 30. Yes. First one, n must be greater than 30. Means that must be a great sample size. Okay. Another one. N is plus. Yes. NP. Oh, this one you will get confused with the what do you call in chapter 3. Chapter 3. This one students always get confused with chapter 3. Chapter 3 is the distribution approximation. Distribution approximation. When distribution approximation means we use normal to do the approximation of binomial. Okay, but now we use normal to do the approximation of bar x. Bar x. That is a little bit different. Okay. If you say NP must be greater than 5, that one is chapter 3. Chapter 3. If you want to use normal to do the approximation of binomial, you must have condition. I know that one is NP must be greater than 5, NQ must be greater than 5. That one is population, estimate population. Normal as the approximate of binomial. Normal as the approximate of binomial. But this one, chapter 4, we use normal as the approximation of bar x. Bar x. Okay, so n must be greater than 3. Another one is we must use CLT. What is CLT? CLT is the short form. Huh? What is CLT, class?
What is CLT?
CLT, I read short form here.
Ah.
What is CLT? Anybody know what is CLT? Huh? Yes, central limit theorem. Okay, means bar x, if you want to use normal as approximation, this one must be based on central limit theorem. Based on central limit theorem, and the sample size must be greater than 30. Then you can use normal as approximation of bar x. Bar x, it is not x. X is under chapter 3. Bar x is under chapter 4. Because many students, they feel a little bit confusing about this one. Okay, now next, if the population is Poisson, same thing, bar x, sample mean, I can also use normal as the approximation, but the first number is what? The second number is what? If the population is Poisson. Okay, NG, you use mu divided by n. Yes, mu is lambda lah. Okay, if I use mu, then mu. If I use lambda, then lambda. So this one, this value is the mean of the population of the Poisson. Okay, so the bar x, the distribution is lambda over n. Yes, and yeah, you have to depends on this one. If this one is lambda, you have to use lambda. Okay, depends on the symbol given. All right, then what is the condition? Do you have any condition for this one to apply normal as the approximation? Yes, first thing must be greater than 30. Another one is same thing, we must apply the central limit theorem. Okay, central limit theorem. Okay, yes, correct, Jia Chong. Okay, now next, if the population, okay, the sample we take from the normal population. If the sample we take from normal population. So, how about the first number and second number? I think the first number is the same. First number is mean. Second number, you just use this one. But the only thing is when you come to variance, you must divide it by n. Okay? So, okay, now, the condition here. Do you need any condition? Tell me any condition here. Tell me any condition if you want to use normal approximation. Here, this one. Jia Chong say no. How about the rest? Sharon Tay say no. Means first about the sample size. Sample size, do we need to be greater than 30? Sample size first. We come to sample size first.
They said no, teacher, no.
No, they say no. Yes, first one is you don't have to say that, okay, sample size must be greater than 30. You can use any sample size. Okay, in case the population is normal, bar x, you use normal. You don't have to say, okay, sample size must be greater than 30. You can use any sample size. Okay, how about CLT? do you need to use the central limit theorem? Central limit theorem? All right, Jia Chong say no. Sharon Tay say no. Yes. If the population is normal and the bar x, you don't have to use central limit theorem. Okay? So, because both are the same one. Okay? So, only binomial and Poisson, you need to use central limit theorem. Okay? So, these are the things you must know. The important thing is the variance, you have to divide it by n. If this one is bar x, remember bar x must be divided by n. If this one is x, then no need. So please don't get confused with chapter 3. Chapter 3 is x only. Okay. Chapter 4 is bar x. That is sample mean. Okay. Now, under sample mean, normally they will ask you to find the probability of bar x is equal to what like that. They will ask you this kind of question. Okay, let's say the question says find the probability of sample mean, bar x is sample mean, less than an a, less than a value a. Okay, what you should do here before you can find the probability?
So is this the answer, teacher? It's already normal distribution, thus no need for CLT.
It is already normal distribution, no need CRT. That one is just now that one. Yes, correct. Okay, Leong On, you're correct. Because it is already normal, then no need to use CLT. No need to use central limit theorem. Yes, correct. You are correct. Okay. So, now in case the question asks for find the probability of sample means less than a value. Okay. Before you can find the probability, what is the very important step that you need to go through? Remember, now you're using normal. You're using normal as the approximation. So, what you must do? You must transform from x bar to what? Because under normal, this one variable should be transformed to what? Z. Yes. Bar x, you should transform to Z score because you are using normal. Okay, you are using normal to find the probability. Okay, so you have to use bar x change to Z, where you use this A minus the population mean divided by this one, square root of this one, standard deviation. This is the very important step you have to transform. X transform to Z, then only use the table, standard normal table to find the probability. Okay, so this is generally, this is overall what are the things about sample mean in sampling. Okay, sample mean. Sample mean, normally the question will ask you to find the probability. Okay, now next we go to sample proportion.
Yes. Ailin,
yes.
Kita break sekejap boleh tak? Sekejap je. Lepas ni kita sambung balik.
Okay.
Okay, stay tuned last.
Tahukah anda tuition online percuma? Ya, pertama di Malaysia. Gandingan para guru menghasilkan yang terbaik, memenuhi keperluan pembelajaran anda. Semua mata pelajaran percuma. Dibawakan kepada anda oleh Akademi YouTuber Malaysia, Inisiatif Didik Malaysia dan Kelab Guru Malaysia. Tahniah, terima kasih.
Okay, welcome back class dengan teacher Ailin. Okay, bagi topik matematik T, sampling and estimation.
Yes. Okay. Just now I forget to make it big. No wonder you cannot see. Yes or not? I forget to make the thing. I forgot to zoom in. Then because I know my slide is very small. I wanted to zoom in when I explain, but just now I forgot to zoom in. Maybe some of you couldn't see that was very small. Okay, now I let you see first. Okay, this is the thing. Okay, I zoom in already. Can you see? Just now I forgot to zoom in. Then you cannot see that was too small. Okay, this is the one. Okay, now we go to. Now I zoom in already. Can you see clearer? Can you see clearer? Just now was small. Yes or not? You should let me know. No wonder you cannot see. Okay, now I zoomed in already. Okay, now we go to sample proportion. Okay, sample proportion, the this one, the symbol for sample proportion. A different book, sometimes they will use different symbol. For here, myself, I use PS. Okay, I use PS. I use PS. Some of the books they use a P, different book, depends on different books. Okay, so when you read the book, you have to look at the book. What are the symbol used for sample proportion? You can use different symbol because it is just a symbol only. What? So any symbol can be used. Different book will use different symbol. Some book they will use not a P, they will use the Greek alphabet, the row as the sample proportion. But the row looks like a P. So some book will use that one, sample proportion. For me, I use PS to represent sample proportion. Okay, so now for sample proportion. Okay, once again, what is the sampling distribution for sample proportion? Okay, just now, can you see my hand or not? Can you see the hand is bergerak? Ada nampak tak? Can see or not?
We see, boleh nampak, very small.
Can nampak the hand? Can Okay,
Yeah.
okay. I'm using the hands as a pointer. Okay, now just now, sampling distribution for mean is this one. Okay, so now for sampling distribution for sample proportion. I cannot. So means that if I don't zoom in, okay, I cannot go to wait. Okay, yes, I zoom in one more time. All right. So for sampling distribution for sample mean, same thing. We will use n normal as the approximation. The first value is population proportion. Okay, population proportion. Then the second value is the variance divide. Remember, you must have the divided by n. So p times 1 minus p divided by n. So this is the sampling distribution for sample proportion. All right. So I have to go back to the normal. Then only I can go to the second one. If not, you cannot see. Okay. So wait. I have to zoom in because too small already, cannot see. Okay, same thing. The question, if the question asks for the probability of sample proportion, same thing. You need to find probability of sample proportion less than A. Okay, now, like just now the question, before you can find the probability, one step is very important. What is the step? Before you can find the probability of sample proportion, one step is very important here. What you need to do?
Okay, come on class. Okay, give the answer. Try.
Okay. Whitehouse. Yes. Whitehouse said you must do continuity correction. Yes, correct. You must do continuity correction. Okay. That is. Okay. You must plus and minus. You must plus and minus. You must plus and minus a value. We call it as 1/2n. Yes, correct. Okay. So we call it as correction. Okay. When is the time you plus? When is the time minus? Okay, let me see. Wait, I always get that.
Continuity correction, the answer.
Okay, wait, let me go.
Boleh cikgu?
Can you see me?
Boleh.
Uh,
Tapi tak ada tu lah, cursor arrow tu tak ada.
Let me, I nanti ya, sekejap share screen. Wait. Why cannot? Because I want to go to the. Kenapa tak keluar?
Teacher cuba.
Because I want to go to this one.
Have you shared your screen again?
Huh?
Kena ni balik.
Haven't shared your screen. You took off the screen.
I took off the screen.
Yeah, yes. You should share your slides again.
Wait. Because I want to bring you go to whiteboard. I want to conteng sikit.
Oh, okay.
Can I change? I go to application but tak keluar application dia.
Share application window.
Window, the whiteboard not coming out. Kenapa?
You don't see anything.
Teacher pakai PowerPoint kan?
Tak, dia nak pakai whiteboard.
Saya nak buka whiteboard.
Tukar app.
Tapi bila saya buka whiteboard tak nampak apa-apa. Kenapa? PowerPoint.
Share another window, teacher insert.
Share another
window. You nak share tu, you share window. Window with the whiteboard.
Window tapi dia tak keluar pilihan whiteboard.
Tak ada dalam screen you tu. Tak ada dalam.
Tak ada dalam pilihan window macam mana?
Maybe it's not window lah.
Yeah?
Maybe it's not window. It's a full screen.
Full screen.
Biasanya dia dalam pilihan what? Yes or not?
Ya, dia mesti ada. Kalau ada dia ada lah semua. The PowerPoint you, your screen, all screen yang buka lah terbuka. All the open screen. Kecil say close the whiteboard and open it again. Close the whiteboard and then open it again.
Okay, yeah, come out already.
Okay, share.
Wait. Okay, yeah, come out already.
Share.
Okay. Okay, can you see?
Yes.
Yeah. So, okay, class. Let me see. Okay, let's say. Kenapa tak boleh jalan? Okay, let's say I have let's say I want to find probability as greater than or equal to 0.5. Okay. So, what is the correction I should do? Okay, what is the correction I should do? plus or minus? 0.5. Okay, let's say n is 50. Okay, let's say n is 50. So we should plus or we should minus, class? Here.
Okay.
Plus or
YH
minus?
should minus half n. 1 over 2n. Minus
Okay.
1 over 2n.
Let's say this one is 0.5. Okay, this is 0.5. You want greater than, and included 0.5. So your interval must start from here. Okay, your interval must start from here. If you want to start from here, you should minus. Yes, correct. Taswin, you should minus 1 over 2n. If n is 50, 2n is 100. Like that. Okay, that is correction. Okay, let's say if PS is greater than 0.5. What is the correction?
Minus.
Plus or minus? Greater than 0.5, not included 0.5. Just now, if included 0.5, so your interval, you have to go to the left-hand side. That's why you minus. But now the second one, I want greater than 0.5, not included 0.5. So your interval should be,
Plus.
yeah, Jiahao said plus, because your interval should be, start from here, greater than, here, greater than, okay? Not included 0.5. So you want to start from here, you should plus. Plus is plus 1 over 100. Okay? So if less than, included 0.5. Plus or minus? If less than, you look at the number line, 0.5. You want less than, you want include this value. So your interval should start from where? Plus or minus here?
Not yet answer. Okay, try class.
Priscilla say plus. Yes, you should start from here. Okay, if you want to start from here, you should plus. Okay, because right hand side you should plus. Okay, then the last one, PS less than 0.5. Okay, less than 0.5. So you should plus or minus. Less than 0.5, not included 0.5. Yes, Taswin said minus. Yes, you should minus. Okay, because less than means you don't want to include, so your interval should start from here. Okay, so to the left, then you minus. Okay, so now we go back to the slide.
Congrats.
Okay, yes, correct. Now we go back to the slide. How to go back to the slide? Wait.
Cikgu tutup dulu. Buka balik PowerPoint.
Okay, now we go back to the slide. So, let me get back. Wait. Cikgu buat besar. Ya. Terlalu cepat. So, cikgu nak zoom in. Sebab you tak nampak lah, kecil sangat. So, you must do the extra step. Okay, this one is correction. Then after that, why I cannot? Oh yeah. Okay, then only you change to Z. Okay, so then only after that you can find the probability. Okay, this is sample proportion. Then I think I have to be fast. Okay,
Yeah.
so
50.
it is already 45. Yes, correct. So now after sample mean, after sample proportion. So before I go to estimation, okay, one thing you have to know is you must know what are the sampling method that you have learned. Okay, because sometimes the question might ask you some question about theory. Okay, so okay, names one or two method about sampling method that you have learned. Can you give me name one method or two method? What are the sampling methods that you have learned? We have learned a few sampling methods. Right? Okay, what are the sampling methods you have learned so far?
One plus.
Sampling method.
Sampling
There are a few sampling method. Please read the nota for sampling method. Sometimes the question might ask you about. All right. Whitehouse said stratified random sampling. Yes. Stratified random sampling is one of the method. Okay. Yes. The rest. X guy said random
Random simple.
tak tepat nama, tak tepat. Slightly different. Right, tepat.
Right, the accurate answer.
Ada not random simple. Tepat sikit. Stratified random sampling, yes, correct. The theory you have to go and read. Taswin random sampling. No, slightly. Ada lagi sikit. Not random sampling. Dia punya nama.
Systematic.
Whitehouse says systematic sampling. Yes. One of the method is systematic sampling. Taswin, your answer is sudah dekat-dekat dah. Yes, Whitehouse says simple random sampling. Yes, simple random sampling. So the name you please give right in correct way. So there are a few lah. So you please go back home, refer the method, how you carry out. Sometimes the question might ask about theory, Okay, so remember. So now we quickly go to estimation. Okay, so estimation, same thing. We have two important element in estimation. Okay, tell me. What are the thing estimation you learn? What are the estimation? Okay, sampling you have finished already. Roughly around these are the things that you learn. Now about estimation. Okay, under the topic estimation, you belajar apa? Miss, you have how many kinds of estimation? I give you the clue. How many kinds of estimation?
Estimation.
Unbiased population. Unbiased population mean is under one subtopic. What is the big subtopic there? Unbiased population variance, unbiased estimation mean that one is under one topic. The other one topic. You have two big topic. Two kinds of estimation. First kind is what estimation. Second kind is what estimation. I give you a hint. First one is point estimation. Then the second one? Yes. Okay. Second one is interval estimation. Yes. Okay. Then only come to, you said the unbiased is under this one. Okay. It's the main element. Okay. That is point estimation and interval estimation. Okay. Now we go to point estimation first. Okay. Point estimation. Okay, so here below, then when you go to point estimation, okay, then you have these three kinds of point estimation. One is unbiased estimation for the population mean. One is unbiased estimation for population proportion. One is unbiased estimation for population variance. Okay, now let me know what is the formula. The first one, what is the formula for unbiased estimate of population mean? How to calculate? What is the formula? We use what to estimate the population mean? This one, the first one, this one. What is the formula? Okay, Priscilla said sum of x divided by n. Yes, Jia Chong said equal to bar x. Yes, because let me see. Okay, yeah, you see. Okay, so we use bar x. Okay, bar x to estimate the population mean. We use generally we use sample means to estimate the population mean. Okay, now how about this one? Unbiased estimate of population proportion. What's the formula? What's the formula to estimate the? I think I have to very fast because 50 already because I give you time to. Okay, now I go. That is sample proportion. That is k over n. K is the number of element with that character that we want. N is the sample size. Okay. Then for unbiased estimate of population variance, it is equal to, I think it's two. Kita keluarkan semua dulu. Okay, I'll make it bigger because you cannot see, it's too small. Okay, so generally for unbiased estimate for population variance, it is equal to, we use a simple head. Okay, head. Okay, sigma head. So it is equal to n divided by n minus 1 times s squared. S squared, this one is the sample variance. Sample variance. But some of the books, some of the book, they combine this one. They combine this one. They directly give you this formula. They combine this one. Means they don't go through this one. That directly they simplify. They give you this one as the unbiased. This one also can. If you say you don't want to go through this step directly, so this one also can. So means you have so many formulas, you know, this one. Which one to be used when during the examination? Which one to be used? It depends on the information given. If the information given is x minus bar x squared, then you have to use the first one. If the information given is x power 2, then you have to use the second one. Depends on what is the information given. Okay, so when you see a head there, sigma head, the topi there, the head there means that one is unbiased estimate. But some of the book, I've read some of the books that they directly use S, you know, they combine the S. So it depends on when you read a book, you want to see that one is unbiased variance or simple. You have to depends on the book, how the book gives the definition. All right. Okay. So now we go to interval estimation. Okay, interval estimation. So, cikgu besarkan because it's too small. Okay, same thing. Interval of, you have two. One is for, we call this as confident interval. Confident interval for population mean, confident interval for this one, population proportion. Okay, so for, alamak, I cannot go. Okay, so for, cikgu keluarkan semua lah supaya senang. Because once I zoom, I cannot. Okay, now, so for confidence interval for population, this one mean, this is the formula. Okay, we use sample mean to estimate plus and minus this one z sigma over square root of n. Okay, this one sigma is variance. In case the variance we don't know, we have to use estimate variance. Okay, for proportion, this is the formula. Okay, some book here they use PS, but doesn't matter because pH and PS is the same. Okay, P to P and PS is the same. Some book will use PS, some book use PH. Okay, the formula here. Then the standard error. Standard error is this one. This is the standard error. Okay, standard error. Now I think I directly go to standard error. Wait. I directly go to standard error and show first. Then cikgu terus pergi ke sini. Mana dia? I directly go to here. Okay, so I want to compare because already time already. So I want to compare the relationship between error, sample size, and confidence level. Because this one is confidence interval for population mean. This one is confidence interval for population proportion. Now I take this one as the example to explain. Okay, so let's say you use sample mean to estimate the population means. We always use sample means to estimate the population mean. Okay, let's say you calculate the bar X under point estimation. Okay, you say that, okay, now I calculate this one is sample mean. Now I estimate the population mean also this one. Okay, this is under point estimation. You use one value to estimate the population mean. After you have calculated the bar X, I said that, okay, now I estimate that the population mean is bar X. But actually, maybe the true value of the population mean is not this one, but somewhere different from the what you estimate. This is what you estimate. This is the true value. Okay, so means here you have a little bit different between the true value and the estimation. So the difference between the true value as the estimation, we call it as error. Okay, then after that, then you say, okay lah, beza sikit-sikit tak apalah. Okay, we can tolerate what? Sikit-sikit tak apalah. But then you have to give me the limit. Up to what limit you can tolerate? Okay, if too big the difference, we cannot accept what. So now I use the plus and minus. You must give me one plus and minus. Okay, the limit. Yes.
It's okay, no need to rush. Okay, because no class after this, you can take your time sikit pun tak apa.
Right. Okay, because after that we don't have class.
Yeah.
Right.
Yeah.
So let me explain this one. This is very important because students always get confused this one. Okay, let's say, okay, sikit-sikit tak apa, but you have to let me know up to what sikit-sikit I can tolerate. Okay, plus how many? Plus how much? Minus how much? Give me a limit. So now I use this one. Okay, minus z sigma over square root n plus z sigma over n. This is the limit. So means this interval, we call it as confidence interval. Okay. So means this is the maximum error is allowed. Okay. If sikit-sikit tak apa, if the mu is inside this interval, sikit-sikit error tak apa. But we don't want the difference between mu and bar X more than this value. Okay, if more than this value means we don't want to accept anymore. So means this one is the maximum error that we allow. Okay, this error, we have many name. Okay, we have many name. Some will say this is a standard error. Some will give margin error. Some will give half width, because width of the confidence interval is the whole thing. This is error is half width. They have many name of this one. Okay, but we know that there is error. That is the difference between the true mean and the estimation mean. So the estimation cannot be more than this one. So that's why we call it as maximum error. It is allowed. So now there are three elements saling bergantung each other. Okay, saling bergantung each other. So when we do the research, always we try to reduce the error. Okay, there are three components. Okay, let's say now I fix the confidence level. Okay, I fix the confidence level. Okay, confidence level I fix. I don't want to change. So now if I want to try to reduce the error, so you see, the error is here. This is the error. So this is error. This is Z is confidence level, and N is sample size. Now these three things related to each other we can manipulate. Okay, so now I want to fix the confidence level. This one Z I want to fix. So the relationship between error and N is reverse proportion. Means when N increase, error will decrease. So means if you want to decrease the error, you must increase your sample size. This is the first one. Okay. Now let's say I want to fix the sample size. I don't want to change the sample size. So how about the confidence level in order I can reduce the error? So when you look at here, okay, now I fix the sample size. Now I only compare error and the confidence level. So error and confidence level, when you see here, they are directly proportional. Directly proportional means when Z increase, error increase. When Z reduce, error also reduce. So means if you want to reduce the error, means you reduce the confidence level. Okay, this is the second case. When you come to third case, okay, now I want to fix the error. Means I don't want to increase my error. I don't want to decrease my error. I want to fix. Error also related to accuracy. Okay, I want to remain my accuracy. I don't want to change. So what is the relationship between the sample size and the confidence level? Okay, now error is here. Now I want to fix the error. I want to change. Okay, so now the relationship between Z and N. So now let's say I pull the N over here. Okay, pull the N going on the left hand side. So means that the relationship between N and Z is direct proportional. Means when N is increased, Z also increase. Okay, so when sample size increase, confidence level also increase. So there's three kinds of relation between these three components. So depends on the question, ask you to fix which one. They want to fix confidence level, or they want to fix the sample size, or they want to fix the error. Okay, these are questions I think come up last year. I think you must understand the relationship between all these things. Okay, do you have any questions so far?
Setakat ni tak ada, not yet.
Okay, not yet. So if you don't have, then I think the revision up to here. Okay, so to help you to recall back everything, all the thing. If you don't have, so I think yes, if they go back home. Oh, now before we say bye bye, then I would like to invite some of you come into our studio here and say something. Okay, Zana, can you send the invitation link to this one? Anybody want to join us and say something and say thank you to your teacher and bye bye and say something because this is your last tuitions. All right. Yeah, it is the link there. The link there. Yes.
Cik Ailin,
Yes.
tapi ada satu soalan from Chan Wai How, why we don't do proportion correction in the hypothesis?
Hypothesis. Hypothesis is testing. Hypothesis testing, yes or not? Hypothesis testing, yes or not? Is this hypothesis testing? Yeah, hypothesis testing. So hypothesis testing is another chapter already. When we do correction, Why we do correction? Because we want to use normal as the approximation to find the probability. Okay, and we use correction because normal is continuous, proportion is not continuous. When you use continuous distribution to find the approximation of non-continuous, the discrete, proportion is discrete, normal is continuous. When you use continuous to do the approximation of discrete, then you use a correction. But hypothesis testing, it is nothing to do with the normal distribution already. That is another chapter. That is chapter 5. So we don't have to do correction. Okay.
Okay. Is it okay good kan? That is your
Okay.
answer. Anyone
So,
let's
anyone?
join us
You want to join
dalam
us and
kongsi?
say something? You can click on the link given there.
https streamyard.com tu. Okay. Join us through the link.
Because this is your last live already. Then after that we say bye bye, sayonara. After that, but don't sayonara. Please come back and support us.
Okay, come on, Priscilla Chin.
Yes, you click on the link, then you come here.
Uh-uh.
Come, don't be shy, and say something to maybe your teachers.
Tashwin, ada lagi tak? JC. Sekejap je.
Is it acceptable if not using continuity correction in this chapter? Okay, you are advised to use is better. Even though now I heard from those who are marking, if you don't do correction, also they mark you they award you the mark. But to play safe, it's better for you to do the correction. Okay, because by right, you should do correction. I heard from those who are marking, saying that for the new coming marking scheme, they will ask you to do the marking scheme will means you need to do the correction. Okay, by right
Ada
you
lagi
need to.
soalan teacher. Why binomial approximate to normal need to do correction in hypothesis testing?
Binomial approximation, I think you mix up these two chapters already. Binomial approximation using normal approximation, that one is under chapter 3. Okay, binomial, if you want to calculate the probability, under hypothesis testing, they have two methods. One is by using the P that I told you just now. The other one is by using normal. I know, by using normal. Okay, if you use normal to approximate the binomial, then you need to do the correction now. Okay, just now the method that I used just now, that is use proportion method. It is not using normal method. Okay, if you use normal method, yes, you need to. If you use normal method, you want to calculate the probability, yes, you need to do correction. Okay, just now I give you the nota, that one, it is not using normal for proportion. Okay, it is using the PPS, that one. Right?
Okay. Ada lagi tak soalan? Kita tengok. Okay, if that's all the question, anyone
So anyone you want to come?
Okay, jangan malu-malu. Okay. Leong. Okay, come on, Leong.
Angie, do you want to come? Just join, because this is your last session already for your SEM 3. Don't malu-malu. Okay lah, I think since it is already time, if you feel malu-malu, it's okay. So good luck class. So I wish you all the best for your SEM 3. Then after that, you sit for your exam on Monday. Okay, all the best class.
Alright. Okay, thanks to teacher Ailin, okay, for this class, okay, petang ni. Okay, so I hope ya semua dah faham ya. Kalau tak faham, okay, tadi kita dah ada session untuk tanya soalan lah ya. Okay, so semua dah selesai. So Isnin exam dia. Okay, so tamatlah kelas kita pada petang ini. Okay, sebelum itu saya nak beri peluang kepada Cikgu Zana okay, untuk beri sepatah dua kata.
Okay. Assalamualaikum and very good afternoon. But it's sad, I feel sad today because this will be the last lesson for all the SEM 3 students. So I wish all the best in your future undertakings, and I hope that you can enter your varsity of your own choice. Okay, so do well, okay, practice. You still have time to practice, okay? You have one more day to practice your exam. Because I always believe practice makes perfect. So please, like Teacher Ailin said just now, don't forget you are a Academy YouTuber supporter, and I hope you still, after dah masuk universiti nanti, you still join us, okay? Alright, good luck, goodbye. Sedih saya hari ni.
So do we have Madam Rosmaya? Tak ada Dia dah keluar. Okay, so okay, tak apa. Alright. So thank you for student semua yang join us. Okay, so sebelum tutup ruangan chat ya, klik butang subscribe, okay, aktifkan ikon loceng, okay, and then share kepada rakan-rakan yang lain, junior-junior kamu akan datang ke ya. Okay, dan kita ada link CJ di bawah itu. Okay, gunakan email e-didik sahaja dan link CJ ini akan tamat tempoh ya dalam 30 minit selepas live ini tamat. Baik, kita ada kelas terusnya cikgu? Ada ya, minggu depan. Okay, pada jam dan waktu yang sama. Okay, dan semua pelajar dijemput untuk ke portal kami www.academyyoutuber.com okay, untuk dapatkan promotion dan info terkini okay, tentang tuition percuma bagi subjek Stpm dan matriculation. Okay, dan selepas pandemik COVID-19 ini berakhir, kita akan tetap teruskan ya kelas-kelas kita secara percuma ini. Dengan itu, ingat hashtag bermula percuma selamanya percuma. Dengan itu, terima kasih semua. Kita jumpa lagi. Bye. Assalamualaikum.
Assalamualaikum.
Tuition online percuma. Tuition online percuma. Layari www.academyyoutuber bagi mengikuti tuition online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Academy YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuition online percuma mestilah Academy YouTuber.
Dibawakan kepada anda oleh Academy YouTuber.